We flipped over to the back side just to look at how to do these. Okay? On the back, we're using some of the calculator features. Andy, could you read 5 for us, please?
Yes, I would be more than happy to. Graph the simplest interest function on the calculator. Find using the value feature the balance after 2 years, 5 years, 10 years, 5 years.
Okay, so first of all, go ahead and write the generic simple interest function on this side so we can see it as we're working. Plus P0 times R times T. I guess we're going to have to go up to the top and get some of that info from number 4. Okay, so backing on up. Andy, can you read 4 for us?
The number question for? Okay, a person invests 5,000, 8% interest rate over a certain amount of time.
Okay, 4A. Myra, how would we write 4A? Simple interest. PT equals using this information. 5,000 plus 5,000 times 0.08 T. We don't know a time. Which function family does this belong to? Guillermo. Yes, last week we looked at function family simple interest. I'll give you a hint. It was either linear or exponential. Linear. C. Name the rate of change. Let's simplify this a little bit. Rate of change is going to be in front of the T. Let's actually multiply that on out. 5,000 times 0.08. 400 is what I get. Did you guys, everybody take 5,000 times it by 0.08? Jerry, what do you get? 400 T. Okay, so the rate of change is in front of the T. It's just like slope. Over the years, you're gaining $400 in interest, so rate of change is 400. Write a balanced function for compound interest. Same info. But compound interest goes different. It goes 5,000 times. Christopher Bernal, if we're talking about compound interest, what goes in the parentheses? I'll give you a hint. 1. We wrote it on the other side. Good. What's our rate? R, what's the rate in this case? Thank you. And where does the T go? Does it go right here? Up top. Okay. Which function family does this belong to? Who remembers from last week? Simple was linear. Exponential. Whoops. Compound was something else. Exponential. Does it have a constant rate of change? Linear looked like this. Exponential looked like that. Does exponential have a constant rate of change? No. Now, here's where we were going to do 5, but we needed the function. Here's the generic formula. Here's this problem. PT 5,000 plus 400 T. Okay, we need to put this into our calculator. Go to y equals. Jerry and Andy, go to y equals.
Hello, beer.
Hello, beer.
Kenya has this.
Okay, clear everything out. 5,000 plus 400, put in an X. Okay, they tell us to use the value feature. So let's go ahead, that's in calc. Go second calc. Second calc. Do you see where it says value?
Yeah, that's number one.
Good. Push enter. Ooh.
With what?
But do you have a blinky X?
Yep.
That's okay. If you can't see your whole thing, that's okay. If you got your blinky X, guess what we're going to do with A?
2 years.
There you go. Each of these A, B, C, D is going to be an X that we put in. So I'm going to push 2, enter. Guess what it gave me? Do you have a Y?
Yep.
Mine has a Y showing up over here. That's going to be the balance after 2 years. So $5,800. Okay, we're going to do it for 5 years. We go again, second calc. That gets us to the value function. Push enter. I'm back to having a blinky X. Oscar, what am I going to put in this time?
5.
Are you Oscar?
No, I'm Uriel.
Oscar, I'm on 5B. I've got a blinky X. Got my finger right on what I need you to say.
5
Do you see that 5 years? Do you see it on your paper? Are you on the right page?
5 years.
5 years. I'm going to put a 5 in, and then I push enter. What do you see for Y?
7 or 7,000?
7,000. Okay. Now, go ahead and do C and D, please. C and D.
Already done.
C and D, please. C and D. Good. Math skills. Excuse me? Well, it hits people over here this time of year.
Right there.
Okay.
Every time it goes, you're like,
Come on, my friends. It helps if you turn it on. Okay, you need to do C and D.
I don't even know what happened, dude. I did it on the fly.
Okay,
she stopped to pick up
now, Jerry, could you read 6 for us?
Oh yeah. Using the intersection feature, thank you, Peter, for reading. The intersection feature, find the time you will take to have a balance of 7,000, 8,000, 10,000, and 18,000.
Okay, now, in the last problem, they gave you years, and that was an X, Sam Markison. Now they're giving you an amount of money, and now you need to find years. But look at the first one, it's 7,000. I've seen that before.
No,
5 years. Silly Miss Morrell. There we go. Now, we've got the 8,000. We got to do intersect feature. So, go back to y equals. You still have the same function in there. You need to scroll down to get to y2. Christian, are you doing this? Sam, are you doing this? You're back in y equals. And you scroll down, so I have a blinky feature at Y2. I put in 8,000. Now I have a Y1 and a Y2. I push second calc again. Second calc, just like we were doing before. Instead of value, you want intersect. Do you see it? What number? Okay, so we go down to 5, push enter. I can't see mine, but let's see if I can get it without seeing. It says first curve, I'm going to push enter. It says second curve, I'm going to push enter. It says guess, I'm going to push enter. And great. I see a Y of 8,000. What does the X say? 7.5 years. I'm hearing a how did we get that? Let's look at it again and see. Again, this is the amount of money. Now we're trying to find years. Go to Y equals. You're going to leave Y1 the same, but use the up-down arrow to get to Y2. Clear out that 8,000. Sam. What are we going to put for Y2 this time? Guillermo?
It's actually, you can just look at the pop-up.
I'm on C. Oh, do we have another one that we got?
C is the answer. That's the answer to C. But
10 years was 10,000?
No.
yeah.
All right, let's do it with the intersect feature. In Y2, I'm going to put 10,000. 1, 2, 3, 4 zeros. And then here's how we do intersect. Second calc. Martine, Guillermo, push second calc. Use your calculators. We're going to use intersect feature. So we push 5, enter. I got nothing. Okay, I'm going to go back. Second calc. Oh, it froze. Beautiful. Oh, there we go. Clear. Y equals. This is what my Y equals looks like. Second calc. Go down to intersect. There we go. I have a curve.
It's second trace.
And now it says first curve. Anna and Isabella, are you there? First curve, I push enter. It says second curve, I push enter. And then it says guess, and I push enter a third time. Enter. Now, I got 10,000. How many years is that? 12.5 years. All right, you're going to have the rest of the time to work on this. Finish both sides independently. I'm going to walk around. We've done each of the parts. You're going to have to enter new functions in for 7. And we didn't finish the front side. I can also help you finish off that other page from Friday if you need help with the page from Friday. Okay, so. There it is. Oh, this is. Friday. Let me give it to people who are absent Friday. Here's somewhere. It could be.
There's 2 of these.
Who else? Myra.
Yeah.
Friday. And who got one?
Oh, what's wrong? No, but you're right.
Alright, almost on, I'm still
Mr. Craig, do you mind helping me pass back some stuff on last week? Okay, guys, you have 2 worksheets to work on. This one you provided, this one's right now.
When is that other one due?
Probably.
Exactly.
I still would.
Okay, so, second down and intersect. Now, when it says first curve, enter. Second curve, enter. Yes, enter.
Yeah, bruh.
And now you're looking for the dotted line.
I wasn't even sure.
Now you're gonna go right to change, yeah. Yep.